Howdy and welcome back. In this lesson video, we're going to go ahead and introduce the binary search tree iterator as we'll define it in this particular lesson. And then we'll go ahead and get into the implementation of some of its behaviors. Since this is a iterator and since we're implementing it as a forward iterator, you're going to have the usual suspects as the behaviors available to you. We're going to see some sort of means to construct an iterator right here, and then the typical iterator key operations following thereafter. We have some ability to dereference the iterator to get the data at the object to which it's pointing, prefix increment, as we'll define here shortly, and then some ability to test to see whether two iterators are pointing to the same element within a sequence. I want to go ahead and just make something very clear that our particular implementation here is going to perform an in-order traversal of a binary search tree. We could have defined this to do a pre-order or a post-order. And in hindsight, I probably should have named this iterator in a way that communicated that it is performing an in-order traversal and not some other traversal. So, I mean, just understand what these things do. It's kind of up to how you define them. And in this particular case, for our particular discussion, it is going to be defined as a iterator that's going to visit the nodes within our binary search tree in order. So if you don't remember necessarily what an in-order traversal was, remember that an in-order traversal is essentially going to process the root of a subtree in between processing the values in the left subtree and those in the right. So if we were performing an in-order traversal of the tree shown here on the right, we'd essentially walk kind of all the way down to the smallest element, all the way left as far as we could. We know that we're there once the last node kind of as far left as we gone, its left pointer is going to point to the null pointer. So we know that 4 is going to be the first node in the in-order traversal. We'll then go back up to 8. We'll visit it and go ahead and write it out. And then we're going to go ahead into its right subtree. So we'll visit 12, but remember, we don't process 12 just yet. We continue to go left as far as we can. So we'll visit its left child. Since 10 is a leaf, it has no left, no right children. We can go ahead and process it. So we see 10 here. We can go back to the parent then. That's going to be 12. And then we need to process the right subtree. So we go down, we see that 14 is a leaf. It has no children. It's processed. And now we need to go back up, right? So we visited 4, 8, 10, 12, 14, which comprises the whole left subtree of our root where this traversal started. So we can finally visit the root, or I guess go ahead and visit the root's data before we begin into the root's right subtree. So after that, we go ahead, we realize 22 is a leaf. Alrighty, go ahead and put its value out. And at this point, we've conducted, however you'd like to phrase it, an in-order traversal of our binary search tree shown here on the right. And notice the in order is communicating that the key values, but remember, we're just considering this data today, is going to be visited in order as they present within in order, in this case, ascending key values, if that makes sense. Okay, hopefully that last bit didn't confuse you a bit, but let's go ahead and get going onto the iterator construction. If you need kind of a recap of this, I did present the recursive algorithm in terms of how we can recursively perform an in-order traversal. And I had a lot of diagrams which showed what was happening kind of within each recursive call with some highlighting, etc. So if this is not fresh, I'd strongly encourage you to go ahead and revisit the relevant lesson. I will say, though, we're not going to be implementing our in-order traversal for our iterator using recursion. Instead, we're going to implement it in a way where kind of the whole state of the process of the traversal is preserved because remember, we're not doing this all at once. We're kind of visiting one node at a time, and there could potentially be some gap between there. So kind of that whole process that we saw before is going to be somehow preserved within the iterator so that when we go to increment, we arrive at the proper node that is next within the sequence as defined by an in-order traversal.